All right, so welcome to the deep dive. Today we are going to take you on a journey.
Oh, this is going to be good.
Yeah, I'm excited. We're going to a real-life mystery that sounds like it's straight out of like a sci-fi movie.
Oh,
We're talking about a strange anomaly in Earth's magnetic field,
okay.
an area of weakened intensity
Uh-huh.
called the South Atlantic Anomaly, or SAA for short.
Catchy?
I know, right? You provided this article from the Greek news site Newsbomb about this, and frankly, I'm dying to figure out what's going on.
Well, let's get to it. So, it's not science fiction at all, first of all.
Okay.
The SAA is definitely real,
Okay.
and scientists are keeping a close eye on it
Makes sense.
because it can cause some serious headaches for satellites and spacecraft.
Ah, okay.
And yes,
All right.
it might even hint at some bigger changes brewing deep within our planet.
Okay, so before we get into the potential space drama,
Okay.
let's lay the groundwork.
Lay it on me.
Where exactly is this SAA, and what does it look like?
Imagine a vast sort of lopsided zone
Gotcha.
stretching from South America all the way over to Southwest Africa. That's the SAA. And within this region, Earth's magnetic field is significantly weaker than in surrounding areas.
So like a dent in our planet's magnetic shield.
You got it.
I know Earth's magnetic field protects us from all sorts of solar radiation, so I can't imagine a weaker spot is good news.
You're exactly right to be concerned.
Okay.
That magnetic field is crucial for deflecting charged particles constantly streaming from the sun.
Right.
A weaker field in the SAA means those particles can penetrate deeper into the near-Earth environment. And that can spell trouble for anything in their path,
Oh, no.
especially satellites.
Okay, so trouble, like what? I'm picturing satellites going haywire, GPS signals getting scrambled, maybe even astronauts getting a little extra sun than they bargained for.
It's not quite as dramatic as a sudden shutdown,
Oh, okay.
but those charged particles can wreak havoc on sensitive electronics. We're talking data corruption, system malfunctions, and even permanent damage to components.
Ah.
It's a major challenge for satellite operators.
So not quite a space zombie apocalypse,
Not quite.
but definitely not something to ignore.
Yeah, keep an eye on it.
It makes me wonder what on earth could be causing this magnetic weak spot.
Right.
Is this something humans have done?
You know, this is really interesting because the culprit lies far beneath our feet, in the heart of our planet. Earth's core is this churning mass of molten iron,
I've heard of that.
and the movement of this liquid metal is what generates our magnetic field.
Gotcha.
But these flows aren't always smooth and even.
So just like an uneven flow in a river creates those little whirlpools and eddies, these irregularities in the Earth's core are causing this magnetic dent.
Yes.
I never realized things happening so deep down could affect us up here in such a direct way.
That's a great analogy.
Thanks.
And to add another layer of complexity, there's a particular structure beneath the African continent
Okay.
called the African Large Low Shear Velocity Province.
Okay, that's a mouthful. What exactly is that?
Think of it as a dense, massive reservoir of rock deep within the Earth's mantle.
Okay.
This province, as scientists call it,
Okay.
is different from the surrounding mantle, and it disrupts the normal flow of molten iron in the core.
Oh, okay.
And it's this disruption that scientists believe is a major contributor to the SAA.
So this dense blob of rock deep underground is messing with the molten iron, creating this localized weakening in the magnetic field above it. Now, that is fascinating. Almost like a magnetic tug-of-war happening thousands of kilometers beneath our feet.
Exactly.
Wow.
It's an incredible example of how interconnected our planet truly is.
Yeah.
We tend to think of the Earth's interior as separate from what happens on the surface.
Right.
But the SAA shows just how much those deep processes can influence our lives and our technology.
Speaking of influence in the article, you sent, it was mentioned that the SAA isn't just sitting still, is it?
Nope,
It's on the move.
you're right.
Okay.
And this is where things get really interesting. Not only is the SAA expanding, but it's also slowly drifting westward and splitting into two distinct flows.
Wait, 2 weak spots instead of one? That can't be good news.
It's definitely a development that scientists are watching very closely.
Okay.
And it raises so many questions.
I bet.
What's causing this split?
Yeah.
How will it affect satellites and space exploration in the long run?
I can only imagine NASA's pulling out all the stops to figure this out.
Oh, yeah.
They must be monitoring this thing around the clock, right?
They absolutely are.
Okay.
NASA has an entire fleet of satellites dedicated to studying Earth's magnetic field, including the SAA.
Wow.
They're trying to understand its movements,
Okay.
predict its future behavior, and develop ways to protect our technology from its effects.
It sounds like a complex puzzle. But tell me, is this a sign of something even bigger happening with Earth's magnetic field? Is this all leading to something more dramatic?
Now we're getting to the heart of the mystery.
Okay, let's go.
Some scientists believe the SAA could be a precursor to a much larger shift in Earth's magnetic field. We're talking about the possibility of a pole reversal,
Whoa.
where north and south magnetic poles flip.
Hold on, pole reversal?
Yeah.
Like compasses pointing south instead of north? That sounds like something out of a disaster movie.
It might seem like science fiction, but it's a real phenomenon that's happened many times throughout Earth's history.
Okay, I'm officially intrigued.
Good.
Tell me more about this pole reversal.
All right.
How often does it happen?
So
Yay.
pole reversals are relatively rare,
Okay.
occurring every few 100,000 years or so. The last one was about 780,000 years ago.
Uh-oh.
So we're technically overdue.
Overdue.
Yeah.
Okay, now I'm a little nervous.
Don't worry.
What exactly happens during a pole reversal?
Okay, so
Yeah.
it's not a sudden flip.
Oh, okay.
It happens gradually over thousands of years.
Okay.
But during that transition,
Yeah.
the magnetic field weakens,
Okay.
becomes more complex.
Yeah. Uh-huh.
And can even have multiple poles wandering around
Right.
before settling into the reversed configuration.
So during that transition period, Earth's magnetic shield would be even more vulnerable.
Yes.
What kind of impact would that have? Would our technology go haywire? Would birds forget how to migrate?
It's certainly a time of increased vulnerability to solar storms and radiation. The effects could range from disruptions to power grids and communication systems
Right.
to potential impacts on the atmosphere and even biological systems.
I never thought about the impact on wildlife.
Yeah,
That's fascinating and a little bit terrifying.
a little bit.
But you said that life on Earth has survived multiple pole reversals in the past, right?
Yes, that's right.
Okay.
It's not necessarily an apocalyptic scenario,
Okay, good.
but it's something we should definitely be aware of
Right.
and studying closely.
Okay.
And the SAA, with its weakened magnetic field, is providing scientists with valuable insights into what might happen during a full-blown pole reversal.
So the SAA is like a preview of what could happen on a larger scale. I'm starting to understand why scientists are so fascinated by it.
Yeah.
It's not just a weird quirk of Earth's magnetic field. It's a window into some of the most fundamental processes happening deep inside our planet.
Exactly. And studying the SAA is helping us understand not only the past, but also the potential future of Earth's magnetic field. It's crucial for preparing for potential challenges
Right.
and ensuring the resilience of our technology and infrastructure.
This is all incredibly insightful, and honestly, I'm already eager to learn more.
Me too.
But before we jump ahead, let's unpack the immediate impact of the SAA a bit further.
Okay.
We've talked about the general risks to satellites.
Right.
But can you give us some specific examples of how the SAA has caused problems?
Sure.
What were the consequences?
Well, one striking example involves the Hubble Space Telescope.
Ooh, famous telescope.
Every time it passes through the SAA,
Okay.
which happens multiple times a day,
Oh, wow.
it goes into a kind of safe mode
What?
where many of its instruments are shut down to protect them from the increased radiation.
Ah.
This obviously limits the amount of data Hubble can collect,
Yeah.
and it adds complexity to mission planning.
So even our most advanced space telescopes have to take precautions when passing through this magnetic dent. That really highlights how real this threat is.
It is.
What about other satellites? Have there been any major incidents?
In 2016, the Japanese Hitomi X-ray astronomy satellite
Okay.
suffered a catastrophic failure while passing through the SAA.
Oh, no.
While the exact cause is debated,
Okay.
it's widely believed that the satellite's attitude control system malfunctioned due to interaction with the SAA's charged particles. This led to the satellite spinning out of control
Oh.
and ultimately breaking apart.
Wow.
A huge loss for the scientific community.
Yeah.
And a stark reminder of the SAA's potential impact.
Wow, that's a sobering reminder of what's at stake.
It is.
I had no idea the SAA could have such dramatic consequences.
Yeah, it's a big deal.
And to think, it's not just about satellites, right?
Right.
You mentioned earlier that aviation and even ground-based infrastructure can be affected. Let's dive into that a bit further.
Oh, yeah.
What happens when airplanes fly through this zone of weakened magnetic intensity?
You're right, it's not just a space issue.
Right.
While the effects on the ground are generally less pronounced,
Okay.
aviation is another area where the SAA needs to be taken into account.
Makes sense.
Pilots, especially those on long-haul flights over the South Atlantic, are well aware of the SAA and have procedures in place to minimize risks.
What kind of risks we're talking about for airplanes?
Well, for one, the weaker magnetic field in the SAA means less protection from cosmic radiation.
Oh.
This isn't a huge concern for occasional flights,
Okay.
but it can add up for frequent flyers and crew members.
I guess.
There are also instances where the SAA can interfere with aircraft navigation systems,
Okay.
particularly older systems that rely on magnetic compasses.
So it's like flying through a slightly weaker magnetic force field.
Yeah, that's a good way to put it.
I can see how that could mess with sensitive instruments.
Yeah, it can.
And you mentioned ground-based infrastructure as well.
Uh-huh.
How does the SAA affect us down here at ground level?
The SAA can induce electrical currents
Okay.
in long conductors like power lines and pipelines. In most cases, this isn't a problem,
Okay.
but it can contribute to corrosion
Right.
or, in extreme cases, even disrupt power flow.
Oh, wow.
Power grids in regions affected by the SAA are designed with these effects in mind, but it's something that engineers have to consider.
So even though we can't see it or feel it directly,
Right.
this magnetic anomaly has its fingers in all sorts of aspects of our technological world.
It really does.
It's a subtle but persistent reminder that we're not just living on Earth. We're living within a complex and dynamic magnetic environment.
Precisely.
Yeah.
And as we continue to explore space and rely on increasingly sophisticated technology, understanding the SAA and how it's evolving becomes even more critical.
This has been a real eye-opener so far.
Yeah, it's pretty fascinating.
It's amazing how something so seemingly abstract like a magnetic field can have such tangible consequences for our technology and even our daily lives.
It speaks to the interconnectedness of our planet and the universe.
Yeah.
The SAA might be a local phenomenon,
Okay.
but its implications reach far beyond that specific region.
Speaking of reaching beyond, earlier you mentioned that some scientists believe the SAA could be a harbinger of an even larger magnetic shift.
Yeah.
A pole reversal.
Uh-huh.
I'm dying to dive deeper into that.
All right, let's go.
What would a pole reversal actually look like? Would it be a sudden flip or something more gradual? And what kind of impacts should we really be prepared for?
It's not a lights-out instant switch, that's for sure.
Okay.
As I mentioned earlier, it's a process that unfolds over thousands of years.
Right.
But during that transition period, things can get a little chaotic.
Chaotic how? Give us the rundown.
Well, as the magnetic field weakens and reconfigures,
Okay.
we could see multiple magnetic poles popping up in unexpected places.
Oh, no.
Imagine compasses going haywire, pointing in all sorts of directions instead of reliably towards north. Migratory animals that depend on Earth's magnetic field for navigation could become disoriented.
I'm picturing birds flying in circles. And what about the impact on technology? Would this be a global EMP kind of situation?
It's not quite as dramatic as a Hollywood EMP,
Okay.
but there would definitely be challenges.
Right.
Satellites would be more vulnerable to radiation damage,
Right.
potentially disrupting communication and GPS systems.
Uh-oh.
Power grids could experience fluctuations and even outages.
This is starting to sound a bit apocalyptic.
A little bit.
But you said life has survived pole reversals before, right? What does the geological record tell us about what to expect?
That's right.
Okay.
Pole reversals are a natural part of Earth's history.
Hmm.
And while they do bring changes, there's no evidence of mass extinctions or global catastrophes directly linked to them.
Okay, that's good.
Life is remarkably adaptable.
I guess so.
That being said, a pole reversal would undoubtedly bring challenges that we need to prepare for.
Challenges like what? Give us a sense of what we might be facing if a pole reversal were to happen in our lifetime.
Well, imagine a world where our compasses are unreliable
Okay.
and our GPS systems are glitching.
Hmm.
Migratory animals might struggle to find their way.
Right.
We'd need to develop new navigation technologies and rethink our approach to space exploration.
Okay.
And we'd need to invest in protecting our power grids and communication networks from the increased radiation.
It sounds like a combination of inconvenience and potential disruption.
It would be.
But it also sounds like an incredible opportunity for innovation and adaptation.
Exactly.
Wow.
A pole reversal would force us to rethink our relationship with Earth's magnetic field and find new ways to navigate and protect ourselves. It might even inspire new technologies and scientific discoveries.
This is also fascinating. It's amazing to think that something happening deep within Earth's core could have such far-reaching consequences for our lives and our technology.
It really is.
But it also makes me wonder, what are the most surprising things scientists have learned about the SAA so far? Are there any findings that have completely blown their minds?
One of the most surprising discoveries is the speed at which the SAA is changing.
Oh,
We've known about the anomaly for decades,
okay.
but in recent years, its expansion and split into two lobes have accelerated. This suggests that the processes driving the SAA are more dynamic and complex than we initially thought.
So the SAA is keeping scientists on their toes.
It is.
Is there any consensus on what's causing this acceleration?
There are several theories,
Okay.
but no definitive answers yet.
All right.
One possibility is that it's related to changes in the flow of molten iron in Earth's core. Another idea is that it's linked to the interaction between Earth's magnetic field and the solar wind.
Oh.
It's an active area of research,
All right.
and there's still much we don't understand.
It sounds like the SAA is not just a static phenomenon, it's a constantly evolving puzzle.
It is.
And given how much our technology relies on Earth's magnetic field, it seems like understanding... What are the biggest challenges scientists face in doing that?
The biggest challenge is the sheer complexity of the system.
Right.
We're dealing with a turbulent, molten iron core, thousands of kilometers beneath our feet,
Yeah.
interacting with a magnetic field that extends far out into space.
Wow.
There are so many variables at play, and it's difficult to model and predict with absolute certainty.
So it's like trying to predict the weather, but on a much grander and more complex scale.
That's a good analogy.
Thanks.
Despite the challenges, scientists are making progress.
Did.
They're developing sophisticated computer models and using data from satellites and ground-based observatories to improve our understanding of the SAA and its potential impacts.
It sounds like an incredible scientific challenge.
It is.
And it makes me wonder, what are some of the most cutting-edge technologies being used to study the SAA? Are there any new breakthroughs on the horizon that could revolutionize our understanding?
One exciting development is the use of SWARM,
Okay.
a constellation of 3 European Space Agency satellites
Wow.
dedicated to mapping Earth's magnetic field in unprecedented detail. SWARM is providing incredible insights into the structure and dynamics of the SAA
Okay.
and is helping scientists develop more accurate models.
So it's like having a team of magnetic detectives orbiting our planet,
Yes.
gathering clues to solve this mystery.
You got it.
That's amazing. Are there any other technological advancements on the horizon that you're particularly excited about?
Another promising area, the development of artificial intelligence and machine learning algorithms that can analyze vast amounts of magnetic field data and identify patterns and trends that humans might miss.
Okay.
This could lead to more accurate predictions of the SAE's behavior and help us anticipate potential problems before they occur.
It sounds like we're entering a new era of magnetic field research, where technology and innovation are allowing us to probe deeper into the mysteries of our planet than ever before.
We are.
It's both exciting and humbling to realize how much we still have to learn about this invisible force that shapes our world.
It is.
But before we get too lost in the future, I want to bring it back to the here and now.
Okay.
We've talked about the SAA's potential impact on technology, but what about the human element?
Right.
Are there any direct risks to astronauts or people living in regions affected by the SAA?
It's a valid concern.
Okay.
While the SAA doesn't pose immediate health risks to people on the ground,
Okay, good.
astronauts and high-altitude pilots do experience increased exposure to radiation when passing through the anomaly.
Right.
This is why space agencies and airlines take precautions, like adjusting orbits and flight paths to minimize time spent in the SAA.
So it's more of a long-term risk than an immediate threat.
Exactly. The levels of radiation are still relatively low,
Okay.
but over prolonged periods,
Right.
they can increase the risk of health problems like cancer. As we continue to explore space and push the boundaries of aviation, understanding and mitigating these risks will become increasingly important.
It's a reminder that even though the SAA is a natural phenomenon, it's one that we need to be mindful of as we expand our technological reach.
Look you.
But it's not all doom and gloom, right?
No, not at all.
We've talked about the challenges,
Right.
but what about the opportunities?
Okay.
What are some of the potential benefits or scientific breakthroughs that could come from studying the SAA?
The SAA is like a natural laboratory for studying Earth's magnetic field. By analyzing the anomaly, scientists can gain valuable insights into how the field is generated,
Okay.
how it interacts with the solar wind,
Right.
and how it might evolve over time. This knowledge can then be applied to improve space weather forecasting, develop new technologies for radiation shielding,
Hmm.
and even enhance our understanding of the search for life on other planets.
So it's a bit like a giant magneto puzzle, and each piece we unlock reveals more about not just our planet, but also our place in the cosmos.
That's a beautiful way to put it.
Huh. Shucks.
The SAA is a reminder that we're part of a much larger system,
Right.
and that even seemingly local phenomena can have far-reaching implications.
This has been a truly fascinating deep dive so far.
I'm glad you're enjoying it.
I feel like I've gone from knowing practically nothing about the SAA to having a much deeper appreciation for its complexity and significance.
That's great.
But before we wrap up this part of our exploration, I want to get your personal take on something.
Okay.
We've talked about the science and the technology,
Yep.
but what about the human dimension?
Okay.
How do you think our awareness of the SAA and the potential for a pole reversal might change our perspective on our place in the universe?
It's a profound question.
I try.
I think the SAA and the broader phenomenon of magnetic field reversals
Mm-hmm.
serve as powerful reminders of our planet's dynamism
Okay.
and our interconnectedness with the forces of the universe.
We often think of Earth as this solid, unchanging sphere, but the SAA shows us that there's a lot going on beneath the surface,
Absolute.
both literally and figuratively.
Exactly.
All right.
And these processes, these invisible forces deep within the Earth,
Mm,
have a direct impact on our lives and our technology.
right.
The SAA is a tangible manifestation of that invisible world, a reminder that we're not just observers,
Right.
we're participants in a grand cosmic dance.
I love that analogy, the cosmic dance.
It's pretty cool.
It captures the beauty and complexity of it all.
It does.
But let's bring it back down to Earth for a moment.
Okay.
We've covered a lot of ground today.
A lot.
From the technical aspects of the SAA
Ah,
to its potential implications for the future.
right.
But before we move on, I want to make sure we address one final crucial question. What can we as individuals and as a society do about the SAA?
That's the million-dollar question, isn't it?
It is.
The SAA is a natural phenomenon,
Yeah.
something we can't simply switch off or control.
Right.
But that doesn't mean we're powerless.
Okay, good.
There are several things we can do to mitigate the risks and
Yeah.
adapt to this evolving magnetic landscape.
Like what? Give us some actionable steps. I'm ready to roll up my sleeves and do my part to protect our planet's magnetic shield.
Well, before you go full superhero,
Okay.
let's start with understanding that protecting the magnetic field itself isn't really the goal.
Okay, so what is?
It's more about adapting to its changes.
Okay.
And the first step in that process is to continue investing in research and monitoring.
Okay.
The more we understand about the SAA,
Yeah.
the better equipped we'll be to predict its behavior and develop strategies to protect our technology.
So supporting organizations like NASA and other scientific institutions is crucial.
Absolutely. They're at the forefront of this research, and their work is essential for understanding and adapting to the SAA.
Gotcha.
But it's not just about funding research.
Okay.
We also need to think about how we design and build our technology.
You mean designing satellites and spacecraft that are more resistant to the effects of the SAA? Like giving them some kind of magnetic armor?
Not quite magnetic armor, but close.
Okay.
Satellites and spacecraft that are likely to pass through the SAA need to be designed with radiation hardening and other protective measures in mind.
Hmm.
This includes things like using more robust electronics,
Yeah.
incorporating redundant systems,
Right.
and developing strategies to shield sensitive components from radiation.
So building more resilient spacecraft, essentially. What about the bigger picture? We've talked about the potential for a pole reversal, and that sounds like something that could have far-reaching consequences.
Right.
Is there anything we can do to prepare for that, besides stocking up on canned goods and learning how to make a fire without matches?
I wouldn't recommend panic buying just yet. Okay, good. A pole reversal is a long-term event, something that unfolds over thousands of years.
Mm.
But we can start taking steps now to build resilience into our infrastructure and systems.
Like what? Give us some examples.
Okay.
What kind of preparations are we talking about?
Think about our power grids,
Okay.
communication networks, and navigation systems.
Right.
These are all critical infrastructures that could be vulnerable during a period of magnetic instability.
Mm.
We need to invest in making these systems more robust and adaptable to changing magnetic conditions.
Can you give us some specific examples?
Yeah.
What does it mean to make a power grid more adaptable to a changing magnetic field?
It involves things like improving surge protection,
Okay.
strengthening insulation materials,
Mm.
and developing backup systems that can kick in if the primary grid is disrupted.
Okay.
For communication networks,
Uh-huh.
it means investing in more resilient technologies like fiber optic cables, which are less susceptible to magnetic interference,
Okay.
and for navigation.
Right.
It means exploring alternative systems that don't rely solely on Earth's magnetic field, like inertial navigation systems and satellite-based positioning.
So it's about planning ahead, investing in robust infrastructure, and developing backup systems just in case things get a little wonky with our planet's magnetic field.
Exactly.
Okay.
It's about recognizing that Earth's magnetic field is not static.
Right.
It's a dynamic system that's constantly evolving. And we need to be prepared for those changes, both large and small.
Well, this has been an incredibly insightful conversation.
It has.
And I feel like I've learned so much about Earth's magnetic field and the mysteries of the SAA.
Yeah.
It's a reminder that we live on a dynamic, ever-changing planet and that we need to be aware of and adapt to those changes.
Well said.
Duh.
The SAA is not just a scientific curiosity.
Right.
It's a call to action, a call to deepen our understanding of our planet, to invest in resilient technologies, and to embrace the interconnectedness of all things.
I think that's a perfect note to end on.
I agree.
Thanks for joining us on this deep dive into the South Atlantic Anomaly.
My pleasure.
We encourage you to continue exploring this topic and to discover the wonders and mysteries of our planet's magnetic heart.
Until next time, keep exploring, keep questioning, and keep diving deep into the knowledge that surrounds us.
All right, sounds good to me.
See you next time.
See ya! We've been talking about how the South Atlantic Anomaly is impacting everything from satellites to airplanes, but I'm still curious about something you mentioned earlier.
Okay.
This idea that studying the SAA could help us understand the search for life on other planets.
Right.
That sounds like a giant leap.
It does, doesn't it?
How are those two things connected?
It might seem like a stretch.
Yeah.
But the connection lies in the importance of magnetic fields for habitability.
Okay.
We know that Earth's magnetic field acts as a shield,
Right.
protecting us from harmful solar radiation.
Okay.
Without it, life as we know it would be impossible.
So you're saying that for a planet to be habitable, it needs a strong magnetic field to protect potential life forms from the sun's radiation.
Exactly.
Okay.
And that's where the SAA comes in. By studying how Earth's magnetic field weakens and changes in the SAA,
Right.
we can gain insights into the processes that might affect magnetic fields on other planets.
So the SAA is like a case study for understanding how magnetic fields can behave in unexpected ways.
Precisely.
Okay.
It's giving us clues about what to look for when we're searching for habitable exoplanets.
Right.
For example, if we detect a planet with a weak or irregular magnetic field,
Yeah.
it might be a red flag that the surface is not well protected from radiation.
That's fascinating. It's like the SAA is not just a window into Earth's interior, it's also a window into the potential for life elsewhere in the universe.
It really broadens our perspective
Yeah.
and highlights how much we still have to discover about the forces that shape our planet and the cosmos.
Speaking of discoveries, let's talk about the research being done to understand and predict the SA.
Okay.
You mentioned some cutting-edge technologies like the swarm satellites and artificial intelligence. Can you tell us more about those?
Swarm is truly remarkable.
Okay.
It's not just one satellite, but a trio, flying in formation
Okay.
and measuring Earth's magnetic field with incredible precision.
Wow.
The data they're collecting is helping scientists create detailed maps of the SAA and track its evolution over time.
So it's like having 3 high-tech magnetic sensors scanning our planet from space.
Yeah, that's a good way to put it.
What kind of insights are they providing?
They're helping us understand the structure and dynamics of the SAA in ways we never could before.
Okay.
For example, they've revealed fine-scale variations in the magnetic field within the anomaly, and they've provided evidence of the westward drift
Right.
and the split into 2 lobes.
So they're giving us a much clearer picture of what's happening inside this magnetic dent. What about the role of artificial intelligence? How is that being used to study the SAA?
AI and machine learning are proving incredibly valuable in analyzing the vast amounts of data being collected by Swarm and other missions. These algorithms can identify patterns and trends that humans might miss,
Right.
and they can help us develop more accurate models to predict the SAA's behavior.
So it's like having a team of super smart computers crunching the numbers and helping us make sense of this complex magnetic puzzle.
Exactly.
Wow.
AI is becoming an essential tool in many areas of science, and the study of Earth's magnetic field is no exception.
Okay.
It's helping us uncover the secrets of the SAA and anticipate its potential impacts.
This all sounds incredibly promising, but I'm also curious about the challenges.
Sure.
You mentioned earlier that the biggest challenge is the sheer complexity of the system.
Right.
Can you elaborate on that? What makes the SAA so difficult to predict?
It comes down to the fact that we're dealing with a chaotic system,
Okay.
one with many interacting parts
Right.
and constantly changing conditions. The flow of molten iron in Earth's core is turbulent and unpredictable.
Okay.
And it's influenced by factors like temperature, pressure, and even the rotation of the planet.
So it's not just a matter of tracking the movement of one or two things. It's like trying to model a giant swirling magnetic soup deep beneath our feet.
That's a great analogy.
Thanks.
And to add another layer of complexity,
Okay.
we also have to consider the interaction between Earth's magnetic field and the solar wind, that constant stream of charged particles from the sun.
So it's like trying to predict the weather, but on a much grander and more magnetic scale. I can see how that would be a headache for scientists. But despite these challenges, are there any promising models or predictions emerging? What are scientists saying about the future of the SAA?
The most recent models suggest that the SAA will continue to expand
Okay.
and drift westward for the foreseeable future.
The split into two lobes is also expected to become more pronounced. So things are going to get weirder before they get better. What does this mean for our technology and our understanding of Earth's magnetic field?
It means that we need to be prepared for a future where the SAA plays an even greater role in our lives.
Right.
We need to continue investing in research,
Okay.
developing resilient technologies, and adapting our strategies for space exploration and aviation.
It sounds like a call to action for scientists, engineers, and policymakers alike.
It is?
But before we wrap up our discussion of the SAA and its potential impacts, I want to circle back to something you mentioned earlier.
Sure.
The possibility of a pole reversal.
Okay.
You said that the SAA could be a harbinger of this larger magnetic shift.
Yeah.
What are the signs that a pole reversal might be on the horizon?
There are a few key indicators that scientists are watching closely.
Okay.
One is the overall weakening of Earth's magnetic field,
Right.
which has been observed over the past century. Another is the movement of the magnetic North Pole,
Okay.
which has been accelerating in recent decades.
So it's not just the SAA that's on the move, the entire magnetic field is shifting.
Exactly.
Okay.
These changes are subtle but significant,
Right.
and they suggest that something big might be brewing deep within our planet.
What kind of time frame are we talking about for a potential pole reversal? Are we talking decades, centuries, or millennia?
It's difficult to say for certain.
Okay.
Pole reversals are not like clockwork.
Right.
They don't happen on a regular schedule.
Okay.
But based on the current trends and historical data,
Yeah.
some scientists believe that a reversal could occur within the next few thousand years.
Okay, so not something to panic about tomorrow, but definitely something to keep an eye on. What would be the most noticeable effects of a pole reversal for people here on Earth? Would we see auroras at the equator? Would our compasses start spinning in circles?
The most obvious effect would be on our compasses,
Okay.
which would point south instead of north.
Right.
And yes,
Yeah.
we might see auroras at lower latitudes than usual. But the most significant impacts would likely be on our technology.
Can you elaborate on that? What kind of technological disruptions could we expect?
Satellites would be particularly vulnerable to increased radiation during a pole reversal. This could disrupt communication networks, GPS systems, and other essential services that we rely on.
Right.
Power grids could also be affected, potentially leading to widespread outages.
It sounds like a scenario straight out of a sci-fi movie.
It does a bit, doesn't it?
But you mentioned earlier that life on Earth has survived pole reversals before.
Right.
How did they manage to adapt?
Life is incredibly resilient.
I guess so.
While a pole reversal would undoubtedly bring challenges,
Right.
there's no evidence of mass extinctions or catastrophic events directly linked to past reversals.
So it's more of a period of adjustment than a doomsday scenario.
Exactly.
Okay.
We'd need to find new ways to navigate, protect our technology, and adapt to the changing magnetic environment.
Right.
But I'm confident that we can overcome these challenges.
It's a reminder that change is a constant,
It is.
even for something as fundamental as Earth's magnetic field.
Yeah.
But amidst all this talk of change and potential disruptions,
Uh-huh.
I'm curious about the scientific opportunities.
Okay.
What are some of the most exciting research questions that scientists are hoping to answer by studying the SAA and pole reversals?
One of the biggest mysteries is what exactly triggers a pole reversal. We know it happens, but we don't fully understand the underlying mechanisms.
Okay.
Another question is how the SAA is connected to the broader changes in Earth's magnetic field.
So it's like a giant interconnected magnetic puzzle, and we're still trying to figure out how all the pieces fit together.
Precisely.
Yeah.
And each new discovery brings us closer to understanding the complex interplay of forces that shape our planet and influence our lives.
This has been a truly mind-blowing exploration of Earth's magnetic field, and I feel like we've barely scratched the surface.
We have.
But before we go even deeper down the rabbit hole, I want to take a moment to reflect on what we've learned so far.
Sure.
What are some of the key takeaways you hope our listeners will remember about the South Atlantic Anomaly?
I think the most important takeaway is that Earth's magnetic field is not static.
Okay.
It's a dynamic and ever-changing entity.
Right.
The SAA is a powerful reminder of that dynamism, and it highlights the interconnectedness of our planet systems.
It's also a reminder that even seemingly invisible forces can have a profound impact on our lives and our technology.
Absolutely.
Yeah.
And as we continue to explore space and push the boundaries of human ingenuity,
Right.
understanding and adapting to the vagaries of Earth's magnetic field will be more crucial than ever.
Well said.
Thanks.
This has been an incredibly enlightening journey so far.
Glad you're enjoying it.
And I'm already eager to dive deeper into the mysteries of Earth's magnetic heart.
Me too.
But before we venture further,
Okay.
let's pause for a moment and gather our thoughts.
Sounds good.
When we return, we'll explore the latest research, the potential implications for our technological future, and what we can do to navigate this changing magnetic landscape.
Okay.
Stay tuned. Welcome back to the Deep Dive. We've been exploring the mysteries of the South Atlantic Anomaly, this strange dent in Earth's magnetic field. We've talked about its impact on satellites, airplanes, and even the potential for disrupting our power grids. But now I'm curious about the people on the front lines of this research. Who are the scientists tackling this magnetic puzzle, and what are some of the most cutting-edge approaches they're using?
There's a global community of scientists dedicated to understanding Earth's magnetic field, and the SAA has become a focal point for many of them. It's attracting researchers from fields like geophysics, space physics, and even computer science.
So it's a truly interdisciplinary effort. I can see how this would require expertise from all sorts of different fields. What are some of the most innovative research projects or initiatives underway?
One initiative that I find particularly exciting is the International Space Science Institute's, ISAI, Swarm Science Data Center. They're using data from the SWARM satellites, which we discussed earlier, to create the most detailed models of Earth's magnetic field ever produced. These models are helping us understand the SAA in unprecedented detail and improve our ability to predict its future behavior.
It sounds like the ISSI is taking a big data approach to magnetic field research. That's incredible. What about other research groups? Are there any specific universities or institutions that are leading the way in SIA research?
There are several, but one group that stands out is the team at the University of Leeds in the UK. They're doing some fascinating work using computer simulations to model the flow of molten iron in Earth's core and how it affects the magnetic field.
So it's like creating a virtual Earth to study the inner workings of our planet. That's pretty mind-blowing. What are some of the key findings or insights that have emerged from these simulations?
Well, they've been able to recreate some of the key features of the SAA in their simulations, including the westward drift and the split into two lobes. This suggests that our understanding of the basic physics behind the SAA is on the right track.
So it's like they're confirming what we're seeing in the real world, but with the added benefit of being able to manipulate the variables and see how the system responds.
Exactly. Simulations are a powerful tool for testing theories and exploring different scenarios. They allow us to ask what-if questions and see how the SAA might evolve under different conditions.
It sounds like there's a real synergy between observation and simulation in this field. Data from satellites like SWARM provides the real-world measurements, and then simulations help us interpret that data and make predictions about the future.
That's exactly right. It's a powerful combination that's pushing the boundaries of our understanding of Earth's magnetic field. But it's not just about understanding the science. It's also about finding practical solutions to the challenges posed by the SAA.
You mean solutions for protecting our technology and adapting to the changing magnetic environment. What are some of the most promising strategies being explored?
One area that's receiving a lot of attention is the development of new materials and designs for spacecraft that can withstand the harsh conditions within the SAA. This includes radiation-hardened electronics, more resilient solar panels, and even magnetic shielding to deflect charged particles.
So it's like giving our spacecraft a magnetic makeover to help them survive the SAA.
You could say that. It's about building resilience into our technology so that it can continue to function even in the face of a weakening magnetic field.
What about solutions here on Earth? We talked earlier about the potential for the SAA to disrupt power grids and communication networks. What can we do to protect our infrastructure?
Well, one key strategy is to harden our power grids and make them more resistant to magnetic fluctuations. This involves upgrading transformers, installing surge protectors, and improving grounding systems.
So it's about making our electrical systems more robust, essentially. Are there any other strategies being considered?
Another approach is to develop backup systems
Mm.
that can take over if the primary grid is disrupted.
Hmm.
This could involve using microgrids, which are small-scale power systems that can operate independently.
So it's a combination of hardening the existing infrastructure and creating more localized, resilient power systems.
Exactly. It's about having multiple layers of protection so that we're not caught off guard if the SAA causes unexpected problems.
It sounds like a lot of planning and investment are needed to prepare for a future where the SAA plays an even greater role in our lives. But amid all this talk of challenges and solutions, I'm also curious about the human element. How do you think our understanding of the SAA and its potential impacts might change our relationship with our planet?
I think it's a powerful reminder of how interconnected we are with Earth systems, even the invisible ones. The SAA shows us that what happens deep beneath our feet can have real consequences for our lives and our technology.
It's also a reminder that our planet is not static. It's a dynamic and ever-changing entity.
Exactly. And as we continue to explore and innovate, we need to be mindful of these changes and adapt our strategies accordingly.
This has been a truly eye-opening deep dive into the world of the South Atlantic Anomaly. I feel like I've gained a much deeper appreciation for the complexity of Earth's magnetic field and the challenges and opportunities that lie ahead. But before we wrap up, I want to leave our listeners with one final thought to ponder. We've talked about the SAA as a scientific puzzle, a technological challenge, and even a potential threat. But what if it's also an invitation? An invitation to explore the hidden depths of our planet, to push the boundaries of human ingenuity, and to embrace the ever-changing nature of our cosmic home.
That's a beautiful way to frame it. The SAA is a reminder that we're part of a dynamic and interconnected system, and that our journey of discovery is far from over.
Thank you for joining us on this deep dive into the South Atlantic Anomaly. We encourage you to continue exploring this fascinating topic and to discover the wonders and mysteries that lie hidden beneath our feet and beyond the reach of our atmosphere. Until next time, keep exploring, keep questioning, and keep diving deep into the knowledge that surrounds us.